Hey, it's Mr. A. So this is going to be our REmastery video for MD2, which is all about interpreting data by looking at graphs. You should have these papers in front of you. If you don't, make sure that you do. You're also going to need a pencil because we're going to write all over these graphs and work on some of these questions together. So before we look at any questions, I like to just observe the data. What's happening? What's going on? So with this one, I noticed that we're doing some sort of a race, a 100-meter race, and it's about the number of swimmers on the y-axis, and on the x-axis, it's all about time in minutes. And I know that if I'm doing a race, the best time is the least amount. So I can see that about, I see 3 swimmers all tied with the best time, whereas 11 swimmers had the slowest time, which is also the most common. And I can see most of my data is within this range over here. Not many swimmers were very fast, so most of them were kind of in that slower category range. So now that I've taken a look at the data and I know what it's showing, what it's telling me, now I can go through and actually answer some questions. Letter A, there were 22 swimmers who finished the race in less than 1 4500ths of a second. Well, what I would do first is I would go through and actually tally up all of the bars. We already saw that 3 swimmers swam it in the shortest amount of time. 2 swimmers were the next quickest. Then we had 9 swimmers in the middle at 1 4000ths, 8 swimmers at 1 4500ths. So this question is asking me less than 1 4500ths, which means that I do not count 1 4500ths. It just says less than. So if I look at the less than, that would be this category right here. So I see that there's 5 in the fastest time, 9 in the 1 4000ths, which I know is not 22. So this would be false. The fastest time in the race is 1 5000ths. Well, we already talked about races and time, and the fastest time actually represents the lowest number. And so if I'm looking at the lowest number of the race, I see that it's the 1 3000ths. And so I know that this is also false. 4 times as many swimmers finished the race in 1 4500ths than 1 3500ths. Take a second. What do you think? 4 times as much in 1 4500ths than 1 3500ths. Well, if you said true, there are 8 swimmers that swam in the 1 4500ths and 2 swimmers that swam in the other. And if I do 8 divided by 4, because it was saying 4 times as much, I do get the 2, or 2 times 4 equals 8. This one is true. One of the swimmers who finished in 1 3000ths minutes swam again and improved his time by 500ths of a second. Well, if I'm improving my time, what was his actual time? What will his time be? Well, if I do 1 3000ths minus 500ths, then that's what's going to be my improvement, because improving is smaller in terms of time and races. So 1 2500ths is actually not on the graph. So that means it would change my graph by adding a whole new x-axis point, 1 2500ths. Very good. Let's take a look at the pictograph on the next page. Go ahead and turn your page here. So Stephanie is comparing some different recipes for banana bread, and the picture graph shows how much flour is listed for each recipe. So if I make some observations here, I can see that recipe B is going to be the most. I see that recipe A is going to be the least. And I really need to pay attention to this key. Each of these represents 1/4. And sometimes it's helpful to actually write what they represent over top of the pictures. So this means she would actually need 1 whole cup of flour for recipe C, because there's 4 of the pictures. So let's take a look. A 4th recipe, recipe D, uses 1 cup of flour more than recipe A. Ooh, 1 cup of flour more. How many pictures, that's important, how many cup pictures would be in a new row for recipe D? So I see that A has 1/4, 2/4, and 3/4 of a cup, and it's saying recipe D uses 3/4 that's A right here, it uses 1 whole cup more, which I know equals 1 3/4. But that's not what the question's asking. It's asking how many pictures do I add? Well, if I look back at my key, 1 picture represents 1/4, and I need to know, well, I need a whole. So I would have 1 picture for 1/4, 2 pictures for 2/4, 3 pictures for 3/4, 4 pictures makes a whole. So how many cups do I need? How many pictures? I need 4. Number 4, Stephanie decides to use recipe A to make banana bread. She wants to double the recipe. How many cups of flour will she use? So if I go back to my picture and I look at recipe A we already found has 3/4, and it's saying that Stephanie wants to double this recipe. So I can do 3/4 times 2, or I could do 3/4 plus 3/4, which I know either way is going to equal 6/4. Man, of course, 6/4 is not on my choice list, but I know that 6/4 can simplify to 1 2/4. Rude. 1 2/4 is not on my choices, but I know that Mr. A has taught you well with equivalent fractions. 1 2/4 simplifies to 1 1/2, which means B. Pedro chose D as the correct answer. How did he get that answer? 6 cups. I bet Pedro just looked at the number of pictures in the pictograph, and he doubled it to get 6 of the pictures, but each picture represents only 1/4 of a cup. All right, you're doing great. Last one. We've done pictographs, we've done bar graphs. We're going to just take a look at line plots here. So again, let's look at what's happening here. We can assume, since it's not noted, that X is going to equal 1 strip. And we can see that they're measuring some tape strips in inches. We've got a tie for the most common with 1/2 and 3/4. Looks like our range goes from 3/4 at the biggest to 1/4 at the smallest. So our range, or the difference in size, would be 2/4 if I subtract those two. I can see that the least occurring would be this 5/8 category right here. Okay, so it says if Miguel uses 2 of each length strip to make a line, how long would it be? 2 of each length strip to make a line, how long would it be? So essentially what I need to do is add up all these values and multiply it by 2 if he uses 2 at each. So let's break it down. I see that there are 1, 2, 3, 4, 5, 6. This is 6/4. I see 1, 2, 3, 4, 5, 6, 7. 7 times 3/8 would be 21/8. I see 1, 2, 3, 4, 5, 6, 7, 8. 8/2 is equal to 4. 1, 2, 3, 4, 5. This would be 25/8. And 1, 2, 3, 4, 5, 6, 7, 8. 8 times 3/4 is 24/4. Or 24/4 is equivalent to 6 wholes. So now I need to add up all of these values here in front of me. So I'm going to first add up the fourths. So 26/4 would be 1 2/4. And if I add that to the 4 and add that to the 6, I get 11 2/4. Then I can go through and add up the eighths. 21/8 plus 25/8 would be a total of 46/8. And now, if I change that to a mixed number, 8 goes into 46. Let's see. 8 times 6 is 48, so 8 times 5 is 40, with 6 left over. Or 6/8 can simplify to 5 3/4. So now if I go through and I add up both of those values, 11 2/4 plus 5 3/4, I get a total of 17 1/4. And it says he wants to use 2 of each. I just need to double that. Well, you can tell me what that is. 17 1/4 plus 17 1/4 equals 34 4.5. Very good. So we've taken a look at bar graphs. Bar graphs is important to look at the x-axis and the y-axis, checking to see where do each of those bars actually line up. Pictographs, all about the key. What does each picture actually represent? Line plots, it's frequencies. You're counting x's. How many times does something occur? Make sure you're paying really close attention to the number of x's in each category. All right, I'm so proud of you. Thank you for doing such a great job. Your score at the end of this video will represent your new mastery score. Have a great day, everybody.